Hello everyone and welcome back to the NPTEL course on Herbal Product Technology and Regulatory Sciences. In the previous session, we saw how to prepare herbs and different extraction methods for herbs which can be there used in the formulations. In this particular session, we will study some conventional herbal formulations. Now, when we study herbs, as in the previous session, we saw that these herbs sometimes contain ingredients which are required to be administered in large doses but are actually present in a very minute quantities. So, in order to take this minute quantities, you will need to consume a large quantity of herb, and as a result extraction is very important. Now, once you prepare extract, you might come across certain drugs which are very obnoxious or not so appealing. Take for example a very simple case of capsaicin, which comes from chili, which is extremely pungent on your tongue, or take a case of momordica, which is nothing but your bitter melon, or karela, which is intensively bitter. Now, in this case, the patient may not want to take such kind of preparations, and it is best that we do some kind of formulation or convert it into something which is more palatable. So, the reason why herbal formulation is there is we saw you require that the herbs need to be stable, which they are not, and as a result extracts convert them into more stable form. So, herbal products or herbal formulations more specifically give us stability, they give us acute dose, they give us consistency not affected by seasonal variation, and as a result these are often formulated. In this session we will be discussing powders, that is your herbal powders, herbal granules, herbal tablets, capsules and syrups. Now let's start with the most simple case, and this is your herbal powders. Now, what are herbal powders? Powders may be something as simple as your churnams which you have seen in the previous weeks. So, when you are talking about herbal powders, this herbal powders may be coming out of organized drugs or they may be coming out of unorganized drugs. That is, they might be cellular, they might be non-cellular. At the same time, they might have different kind of origin. Some of them come from plant material, some of them from animals, some of them even from minerals. So, depending upon what the sources are, let's take a very simple case of plant powders. Now, plant powders, when I have to give you example, you can think about something like your shatavari powder or even something like your triphala churna. Now, shatavari is generally given for lactating women, whereas triphala churna is given for enhancing a gastrointestinal or GI health. So, these are plant-based powders which are consumed. So, for plant-based powders, the very first thing that you take is you procure the plant material, clean it nicely and segregate it. Now, once the plant material is obtained, maybe from the wild or from the cultivated sources, the next thing is you have to reduce the size. Now, because you have to consume it as powder, now imagine your garam masala. You cannot eat your cinnamon bark as such because of its texture, because of its consistency, but if it is given as a cinnamon powder, it is much easy to chew as well as to assimilate. So that is why once you receive the plant material, the next thing for ease of administration of powders, we do a size reduction, and that's where they gave their name powders from. Now, when you come to size reduction, depending upon the nature of the plant or animal or mineral sources, you require drying step. Now, these steps may be intermittent, like say for example, a plant may be extensively fleshy, like your cucumber. So, in that case, slicing involves slice reduction, drying. Once the drying is done and your cucumber is completely dehydrated, again they'll do a size reduction to convert it into powder. So, depending upon the moisture content, the consistency, your drug material intermittently is size reduced and dried to obtain a superfine powder. Now these superfine powders are often passed through meshes which ensure consistency, otherwise if they are thick particles you will get gritty feeling on the tongue. So initial powders are passed through 40 mesh, but subsequently depending upon the nature that they are desired and depending upon the industrial application of that, the powders might even be passed through 80 or sometimes even 120 mesh. So once these powders are size reduced, dried so that the moisture content is optimum, the next step is mixing. Now when you have a single herb preparation like a shatavari powder, there the mixing is not required, but it just kind of moving it to ensure consistency. But imagine something like a triphala churna, wherein you have 3 herbs. If it is not properly mixed and if it is a bigger batch, you might end up predominantly consuming one of the herb over the other, and hence mixing is a very vital stage. Not only that, in Triphala Churna the ratios of all these 3 phala, that is Harda, Bheda and Amla, are equal, but in some cases you might have one of the herb which is present in minute quantities and other herb which is present to the 10 times more. In that case we use geometric progression method. That means the quantity of the herb that is least is added first, slowly other quantities are added in increasing amounts. So if I have 3 herbs, which is one is like 10 gram, one is 100 gram and one is 10 kilo, I will take 10 gram first, mix it in 100 gram and then mix it with your 10 kilo powder, so gradually increasing in concentration. So that is one way to ensure uniform mixing. At the same time, it is, like I said, depending upon the sifting, we ensure that the particle size of all these 3 powders are very close. Otherwise, if there is ununiformity in particle size, that will lead to segregation. So again, sifting, grading is done to ensure that there is no segregation, and thereafter your powders are packed in hermetically sealed containers. Now these containers are hermetically sealed so to ensure that the moisture doesn't re-enter. Otherwise, if you have something like a carbohydrate like acacia, or if you have something which is moisture sensitive, which might deteriorate in presence of excessive moisture, or in some cases in Ayurvedic preparations there might be salts or minerals, or in some cases even bhasmas. So these things are, the salts especially and the minerals are sensitive to moistures, and bhasmas you need to mix them very well because they are in small quantities. So this is properly mixed and packaged and labeled. So these are the powders and this is the formulation method. Once you have your powders, you carry out the assessment of powders by different quality control methods. So what are the different quality control methods? Let's see them one by one. The very most important is particle size distribution. You might have come across like this 5 powders, but if they are not same in particle size, they will segregate in the container itself, leading to you taking a predominantly one herb at the top and a finer herb which might remain at the bottom. So particle size uniformity and particle size distribution is seen. Nowadays that is done with a well calibrated scanning microscopes. Then you see angle of repose. So what is done here is your powder is dropped and the flow properties are checked. So you can drop it on a paper with the help of a little wider stem funnel, and then you see the heap which is formed. Somewhere you take the height of this heap as h and radius of this heap as r, and if you say your theta, angle of repose is tan inverse h by r, that is height is to radius, that gives you angle of repose. The smaller the angle of repose, better is the flowability of the powder. The next thing to do with the powder is the density. You might see that some powders loosely packed whereas some powders form compact masses. That also affects the packing and the flowability. So what is done is you pour a specific quantity in a measuring cylinder, you see the density as mass by volume, then you tap it for a particular time till you get a fixed volume on it, that is all the powders kind of settle in and level in, there is no change in volume, and that is what is called as your tap density, and based on that you will get your Cars index, again the smaller value of cars index indicates a better flow properties. Not only that, whenever it is a plant material, you can also see that microscopic attributes, particularly some tissues like your xylem, phloem, cork cells, or certain parenchymatous tissue which are very unique to the plants should be seen even after they are added. Otherwise what will happen is the manufacturer, if they just add 2 out of 5 powders, and if we don't assess it, the 3 others might go missing. In order to ensure that, we can do one more test, and that is qualitative and quantitative analysis. Now this is more accurate than microscopy. The reason being, imagine if you have already extracted your actives from the plant material botanically will remain the same, so it will show you xylem phloem, but it will be devoid of any actives. So in this case, a qualitative analysis like a TLC or a quantitative analysis like a HPLC or any chromatography will help you in identifying the content. Like in ashwagandha, how much quantity are your vithanolides. So ashwagandha powder will be ashwagandha powder in under microscope, whether it contains vithanolides or not. But the activity is because of vithanolides, so you need to do qualitative and quantitative analysis to ensure that your ashwagandha powder contains your vithanolides. Now moving on to the next dosage form, the next convenient dosage form is capsules. The reason being, many a times the powder, like I said, may be hygroscopic, not so palatable, may be pungent, bitter, not so good in taste, and may have a gritty consistency. In that case, a easy way is just pack this powder in the capsule shells. Now this capsule shells come in 2 variants. You have the gelatin variant and you have what is called as vegan variant. The gelatin variant is obtained from bovine bones, cartilages, from wherein different grades of gelatin are obtained. This gelatin is then fabricated into 2 types. One which is called as your hard gelatin capsules, wherein you have hard shells, or soft gelatin capsules wherein you have more pliable or soft shells. Take for example pudin hara, and here what you see in the image out here is an example of hard shell. Now depending upon the capacity, you might have a very tiny size like a size 5, which can fill in terms of volume about 130 microliters, or you might have bigger size. So it goes reverse: 5, 4, 3, 2, 1, 0, 00 and 000, wherein 000 is the largest size and that can hold up to 1.3 ml of your volume. So depending upon the capacity, you have different capsule size in hard gelatin capsules, and you can either fill in your solids or you can fill in your liquids or you can fill in both. So nowadays the capsules are very stable and pliable to both. So you can, if it's solid, you can do solid fill, you can fill or you can fill in your extracts, you can fill in your resins, or you can convert it into what are called as tiny granules, and those you can fill in. Soft gelatin capsules generally are the ones which are preferred for liquid fill, but in some cases solid fill is also done. These capsules are little more pliable and soft. Now in addition to that, for people those who are vegan and have vegan choices, we also have vegan capsules which are made up of HPMC, that is hydroxypropyl methyl cellulose, or it can be made up of microbial polymers such as your pullulan. So pullulan base and HPMC base are again, as you can see in image, transparent capsules wherein you can add opacifiers or colors if you want to make it opaque. They come in the same sizes and can be used for solid fill as well as liquid fill capsules. So they are filled in with powder and then locked in with the cap. This is done by help of machine, and then once they are done, you can just need to put in generally in a aluminium foil or in a blister packing. Why? Because they are very sensitive to moisture. So moisture content in the capsule shells is generally between 12 to 16%, but during the monsoons what may happen is because of humidity the capsule shells might turn soft. So it is necessary that you pack them in aluminium foil or your blister capsules. Once you have it, you can do the quality control test. The quality control parameters of capsules includes capacity. So if you filled in like 10 capsules, how much volume did each of this capsule take, how much weight did each of this capsule take, was there any variation, because that weight variation is again corresponding to your doses. So you need to be careful. Then moisture permeation, like I said, its moisture content of the hard gel capsules is kept constant between 13 to 16%. Now if it is more, they turn soft, and sometimes if it is a liquid fill capsules, you need to take care that there is no permeation, otherwise your capsules will get distorted. Likewise, the extraneous moisture should not be entering inside the capsule as well. Then for such capsules which are liquid fill, you do what is called as leak test, where they are kept on a paper or they are kept in a vessel and checked for any leak. Generally a butter paper is kept where you can actually visually see if any of these capsules is leaking. Then you can do the disintegration. For disintegration, generally a basket with about 6 tubes is taken, and inside each tube is put in your capsule, and it is weighed down by a metal coil, and then it is dipped and picked up. So how much time it takes to disintegrate, that is break and release its content, is called as the disintegration time. Not only that, we also see the dissolution time. This mimics what happens in our stomach as well as in intestine. So it consists of numerous basket kind of apparatus, where again for your capsules you have, depending upon the specification, a mesh basket, and inside this mesh basket your capsule is kept. Now this mesh basket rotates at a particular RPM in a media, and this media is made to simulate our gastric pH like pH 1 or even intestinal pH for certain amount of time as specified in the monograph. So how much time the capsule takes to dissolve, how is the drug release from the capsule matrix, is assessed by the dissolution test. Now moving on to the next formulation, the next formulation are granules. Now as compared to powders, granules are more compact masses which are larger in particle size. Now you might come across granules which we take directly, as you must have seen your instant coffee many a times comes in forms of granule, or even many a time your shatavari or other powders along with sweeteners are formulated as granules and sold into tiny sachets. So there are two basic methods to make this granules: wet granulation as well as direct compression. In wet granulation, what is taken is your plant material is taken and that is soaked with water, or in some cases a very non-aqueous solvent such as alcohol, like your IP, isopropyl alcohol. Now when you take your powder and disperse it, you moisten it, so you will get a liquid dough like a chapati, and slowly this is dried. What happens is, during drying, this liquid starts evaporating and your solids come together and form clusters. So they initially form liquid bridges wherein the liquid join to each other, and gradually, because the liquid dissolves some things, as the water evaporates or as the solvent evaporates, the solubilized compounds form solid bridges. So eventually it forms a compounds or compact snowball like arrangement, and those are your dry granules. It's just kept in oven for some period of time to ensure that the solvent evaporates and you get your granules just by passing it through certain mesh size. So this might be done previous to drying, so that to ensure that your granules dry quickly and to a particular mesh size. The more easier way it is done is by direct compression. Now this is something which is preferred for herbs, because the more moisture you introduce, some herbs might swell, and that might increase the problem for us because they might not dry as quickly, especially if they are carbohydrate rich mucilaginous containing drugs. So in that case, you can just have or imagine a direct compression method, and this involves two methods. One is slugging. As you can see, the powder is kept on the bed and it is compressed between two presses, which produces a slugs, and these slugs are then broken by passing through the mesh. Alternatively, what it can be done is you can have this as a uniform mass, and you might have something like a roller machines. So what will be the difference is, rather than having particles here, you will produce a bar or a slab of uniform size, which is then tapped and broken, or applied pressure and broken, which is giving you a very similar results. Direct compression via slugging and roller compaction is more preferred for herbal materials. Now when it comes to quality control for granules, we need to see again the content uniformity, and proper mixing ensures it. Moisture content, especially if it is done via wet granulation method. Particle size, because it needs to be uniform, otherwise the granules will separate based on their density. Flowability, the same like powders, even granules need a proper flow, otherwise if you are going to pack them in your capsules or any other packets, it might not flow uniformly. Then you have your density, similar like your powders, even the granules need to be assessed for their tap and bulk density in order to ensure uniformity of content while packing. And then dissolution. So in some cases, when they are sugar coated, polymer coated granules, how much time it takes to dissolve and release the drug, that is also something which is assessed properly. Now moving on to the next one, and these are again a very common herbal formulations obtained in market, and those are herbal tablets. Now herbal tablets depends entirely on what kind of preparation. In some cases the herbs are converted into tablets. Take for example like your hajmola. That's nothing to do with extracts. What is done is most of your herbs are compacted, converted into a compact tablet, and you can consume it. In some cases your extracts are formulated. So here, depending upon the final dosage form, depending upon the requirement, you will select your herb, you will do the size reduction, if need be you will do the extraction, then you do the granulation, very similar to the previous method. Again, mostly you use something like a cross carmelose sodium, which can help you in direct compression along with your binding and disintegrating agents that are added. Once these are added to your powders or extracts, you do the punching, that is pressing. So there is generally a die like a well, and in this the powder is pushed in. So there is a press below, there is a press on top. When the pressure is applied, what happens is the powder presses to a disc like tablet, and eventually this comes out, or this pushes it more, so that it is pushed out of this die and you get your tablets. Imagine this process done very fast, you will get multiple tablets. Now tablets in market come out in different categories. You have coated tablets. Now you might have uncoated tablet as well. Say for example the crocin or hajmola that you consume are good example of uncoated tablet. In some cases, when the stomach acid destroys your active compounds, it is coated by a polymer like your cellulose acetate phthalate, or in sometimes it is just coated by a simple sucrose based coating like your M&Ms or gems. So this coating will ensure that the drug attributes are not seen. In some cases you can see such herbal material, but the consumer may not want it. So coating will conceal that look. Then you have effervescent tablet. Take for example your nowadays you have those quick relief tablet like your Disprin, aspirin. When you put in, they give you fizz. Even your Eno, which are used as antacids. Nowadays numerous herbals are also formulated in this. So they contain what are called as effervescent combinations like a acid and base. So citric acid and sodium bicarbonate, which will react to release your CO2 when they come in contact with water. Then you have your chewable tablets like your Digene tablet or antacid tablets, which are pretty hard and they need to be chewed. The reason is some cases they are very big in doses also. So if you take it, there is a good chance of choking. So you chew it, convert it into smaller particles and then take it. Then you have your mini tabs. You can see here they are so tiny that they could be filled in your capsules as well. But they are not clearly circular granules. You can see they are disc. So they are punched very carefully using specialized machines or certain extruders and cutters, and there you have your mini tabs with a little like a half millimeter to 1 millimeter or even 2 millimeter size. Then you have your control release. In this, different matrices are used along with herbal materials or actives to ensure different type of release pattern. So this is, say for example, the drug releasing. Okay, I'm just putting the drug release as release, and this was versus time. So sometimes when you consume it, the drug is immediately released like a effervescent ENO within 2 minutes, and then there is subsidence. In some cases, there is something called as delayed release. So initially they might not release in the stomach, but they might release somewhere in your intestine. In some time there is something called as pulsatile release. So they will be on and off. Okay. And then in some cases there will be sustained release. So gradually over a period of time you will see a different kind of release. So depending upon the polymers, you can control the rate of release of drugs. So you have your CR, and then you have your floating. In floating, it's an interesting application inside your stomach. If you want to keep something, the normal residence time is somewhere between 20 minutes to 1 hour. If you want to keep it for more longer period of time, you have to keep it floating on top. Generally involves an air bubble which helps it float, or a very light polymer which has density less than your GI secretions. So because of that density, they float up and they don't get drained during the stomach drainage period. Coming to quality control, you have to ensure each tablet weighs uniformly and has same content like 100 mg of ashwagandha. Then you have to check the hardness, otherwise what happens is if they are not hard enough, they'll just crumble during transportation. So you need to check for hardness. Generally it's done by a Monsanto tester. Then you need to check for friability. When it is processed by an industry, there is something called as friability machine. So it is like a circulatory machine. Imagine something like your tumble dryer which keeps on dropping the tablets. So about 100 such rotations are made with the tablet, and they've seen that how much chipping or how much weight loss happens. Generally the weight loss that happens due to tumbling effect should be less than 1%. Then disintegration, same like your capsules, wherein you have your 6 pipes, that is your 6 tubes inside a rack, and then it kind of continuously dips and lifts, and you will see how much time it takes to break into its granules and release the drug. That is your disintegration time. And the dissolution time, same like your capsules, wherein you have a basket, and inside the basket, depending upon the specification. So this is your basket, and this is sometimes if you are talking about a basket type of arrangement, depending upon the capsules. So your tablets might be filled in this, or alternatively in some cases there are paddles. Okay. So this paddles will continuously stir the media, and your tablet lies somewhere in between here at the bottom. So it kind of mimics the GI fluids rotation set at a particular RPM at about 37 degrees Celsius, and you see how much drug is released over a period of time. And yes, content uniformity is utmost important to ensure right efficacy. Now moving on to the next and the last dosage, of which is used in conventional, and again there are numerous formulations, and that's your syrup. Now this is an example of liquid preparation as compared to the previous ones. So here you take the plant material, you do the size reduction, and you prepare your extracts. Now syrups are mostly water based preparations, so it's preferred that the compounds that you are interested in are more hydrophilic or polar in nature, and generally the extracts that are taken to be dispersed here are water based, that is aqueous or hydroalcoholic. Generally organic solvent extracts are not preferred here because the dispersion becomes a problem. So these extracts are taken, they are concentrated. Generally syrups contain up to 66.7% of their weight by sugar, and as a result there is very little volume of water which is available for dispersion. So that volume of water is taken, your extract is dispersed in it depending upon the dosage, and slowly your syrup base is added and stirred. Now as it is being added and stirred, you will see that the extract disperses properly. So if it is a polyherbal formulation, you need to take that little volume of water, disperse most of your extracts and then add your syrup base. Once that is done, you need to filter it, otherwise because it's become very viscous. So in many cases this filtration is done hot via a cloth based or a muslin based filtration, or sometimes via cotton wadings. Now once that is done, it is seen or checked for its clarity, it's checked for its solubility so that no particles are left undispersed, and then it is packed. Now generally quality control for syrups are different because it is a liquid. So in this case what you need to do is organoleptic, the taste, the flavor. You need to check for viscosity, the flowing properties, generally done by rheology experiments. You need to check for specific gravity. This determines the sugar content, and if the sugar content is less, you will need to add preservatives. With good sugar content, the sugar acts as a self-preservative. Clarity, so that all the extract gets dispersed, and then quantitative analysis, are the compounds really there in your formulation or not. So you can do it by phytochemical test to see if they are present or absent, or you can do it by HPLC to see how much of that compound is absent. Irrespective of all of this, with regards to the previous formulation, you still need to do general quality control methods. Now this non-specific quality control methods for herbals include microbiological testing, because they are from plant sources, they might contain bacteria, funguses, even pathogenic organisms. So they may not be sterile, but they need to have certain control or limits of microbes, many a time not less than 1000 CFU per gram or so, and absence of pathogenic microorganisms. You need to really check for aflatoxins, because if fungal growth has happened, especially aspergillus, they give rise to this mucotoxins which might be proving fatal to the cattle, to humans, especially to the children. Then you need to check for heavy metal impurities which might cause disease conditions. Then pesticidal residues, many a time herbal materials are laced with pesticides. So when you prepare your extracts, they get concentrated and we might be consuming it, leading to bioaccumulation. So this is again an important parameter, and stability testing. Whatever formulation you prepare, you need to check for its stability so that the formulation or preparation is conducive towards its shelf life. So here are a few advantages of your conventional formulations. With conventional formulation, as compared to your herbs, you get accurate dosing, because many a times you use standardized extracts with respect to the active principle. Formulations help you in taste masking, especially bitters you can coat it, or pungents you can take care of it by putting them in the capsules. When you formulate it, the shelf life increases as well as the storage. So formulations as compared to your raw material can be conveniently stored compactly without the risk of deterioration, and their shelf life is also enhanced. And nonetheless, herbal materials, when you kind of prepare conventional formulations, they are cost effective and more available all seasons as compared to the native herbs. So here are a few references if you wish to read more about this topic, and thank you everyone for your patient listening. Thank you.